What if the universe isn't, just random? Like, what if every single chemical bond in your body, the exact twisting shape of your DNA, and, well, even the literal physical existence of the human soul could be calculated using one single simple math equation?
It sounds like sci-fi,
Yeah.
but that's exactly what we're looking at today.
Right. Today we are cracking open a document that attempts to rewrite the entirety of physics, chemistry, and theology using nothing but the golden ratio. Welcome to the deep dive.
Yeah, thanks. It is genuinely, I mean, it's one of the most staggering things I have ever
Yeah.
read. We are looking at a text from 2025. It's titled TDUFT Chemistry Physics V2,
TDUFT.
right, which stands for Transdimensional Unified Field Theory. And it was authored by George James Dukas.
And our mission today is to take you, the listener, on a guided tour of this massive architecture. I don't even really want to call it a theory because theory feels way too small for what this document is actually attempting.
Oh, absolutely. It's not just a theory. It is a completely unified deterministic blueprint of reality. I mean, it claims that we have fundamentally misunderstood how matter interacts, how elements are formed, and like you said, how consciousness itself operates.
Exactly.
The foundational claim of this entire massive text is that the universe is built on a single geometric equation, specifically the quadratic equation 6 by dollars equals x plus a to 1.
Which, if you solve that, you get phi, right?
Right. You get phi, the golden ratio, which is roughly 1.618.
Uh-huh.
TDUFT basically argues that this isn't just, a pretty ratio found in sunflower seeds or Greek architecture.
Yeah, stuff you learn at high school art class.
Right, exactly. It claims it is the mandatory, inescapable physical law governing literally everything, from a single hydrogen atom all the way to the afterlife.
Now, a very important disclaimer before we dive into the deep end here. We are not here today to validate or endorse or scientifically verify any of the claims made in this text.
Definitely not.
And we are certainly not taking sides on the really profound and honestly pretty wild theological and philosophical ideas it introduces later on. Our goal is strictly exploratory.
Right. We just want to map out this sweeping intellectual framework.
Yeah.
We want to see how the author connects, like the periodic table, to engineering and biology and eschatology.
It's just an incredible thought experiment that asks us to completely suspend our current reliance on quantum probability and instead, well, embrace absolute deterministic geometry.
And to really understand how this theory reshapes the universe, we have to start by looking at what it's trying to tear down.
Right, and it comes out swinging at modern quantum chemistry.
Well, it takes direct aim at the very foundation of molecular physics. Because right now, if, say, a pharmaceutical company wants to know how a new drug molecule will behave.
Or a materials lab wants to design a new alloy or something.
Exactly. They don't just look at a simple diagram and know the answer. They have to run these massive simulations using something called density functional theory, or DFT.
Right, and from what I gather, DFT is essentially this incredibly complex guessing game, computationally speaking. Is that fair?
Yeah, that's a really good way to frame it. In standard quantum mechanics, we treat electrons as probability clouds, right? Wave functions.
Right. We don't know exactly where an electron is.
Exactly. We only know the probability of where it might be.
Yeah.
So if you want to calculate how strongly two atoms are going to bond, you have to use these massive supercomputers to solve literal billions of electron integrals.
Billions.
Billions. You are calculating the overlapping probability clouds of every single electron in the system.
Okay, let me just make sure I'm picturing this right for the listener. It's like trying to understand how two complex, jagged gears are going to lock together, but instead of just looking at the actual shape of the metal teeth, we're trying to calculate, I don't know, the wind speed and gravity and the friction of the air around the gears to guess if they'll turn.
Yes.
And it takes thousands of CPU hours just to get an approximation, and there's still a big margin of error.
It is computationally exhausting and fundamentally approximate. So TDUFT steps in and says, this is absurd. The gears don't lock together because of probability. They lock together because of their physical shape.
Oh, wow.
Yeah. The text completely replaces those probabilistic wave functions with what it calls phi shell occupancy.
Okay, phi shells. Let's break that down because this feels like the core mechanism of the entire theory. What physically is a phi shell?
So in this framework, electrons do not exist in random probability clouds at all. Instead, the geometry of the universe provides these specific deterministic shells that are strictly dictated by the golden ratio.
Okay.
The theory basically posits that as energy structures itself into matter, it naturally folds into these phi-based geometries. Each shell has a precise capacity, and each shell is assigned an index number, which the text calls a K shell.
So instead of the standard atomic orbitals we learned in chemistry class, the secretolars and orbitals, we just have this hierarchy of K-shells. And these collet shells act as the literal physical hooks for bonding?
Precisely. When a K-shell isn't completely filled with its maximum capacity of electrons, it has what we call a vacancy.
Hmm.
Now, in mainstream chemistry, a vacancy is just, well, a missing electron.
Right, just an empty spot.
But in TDUFT, a vacancy is a literal geometric hook. Chemical bonding isn't about two fuzzy electron clouds overlapping in space. It is strictly about two atoms finding perfectly matching geometric hooks and locking together.
Like puzzle pieces.
Exactly. And the text calls this physical locking mechanism torsion resonance.
Okay, torsion resonance, but how does the text actually back this up? Because it's one thing to just say, it's all geometry. But in physics, you have to show the math. You have to prove it yields the correct energy.
And this is where the text gets incredibly aggressive in its claims. To translate pure abstract geometry into physical measurable energy, TDUFT introduces a universal constant.
Okay, what's it called?
It's called the Intor constant. It stands for energy torsion. The exact value is 0.00075422 electron volts.
Wait, let me stop you there. What does that constant actually do? Because throwing a number out on a page is easy, but what is the actual mechanism?
Think of it as a conversion matrix.
Yeah.
Geometry itself, like angles, ratios, kettle shells, it doesn't have mass or heat. It's just abstract math.
Right.
The Intor constant is the theoretical threshold where that abstract golden ratio math scales into the physical thermodynamic reality of our universe.
So it's like the energy cost.
Yes.
Yeah.
It is the exact amount of energy required to basically flex the fundamental vacuum of space into one of these specific geometric shapes.
Okay, so it's the literal bridge between math and matter. How does that apply to an actual molecule? Like, say, just normal hydrogen gas, 282 others?
Well, hydrogen is the simplest molecule, so it's the perfect test case. Standard chemistry uses those massive supercomputer arrays to approximate its bond energy.
Right, the guessing game.
But TDFT points out that hydrogen sits at what it calls the Kelly-1 shell. It has a single 5 vacancy. So when two hydrogen atoms meet, their Kelly-1 vacancies hook together in a torsion resonance.
And the math, how does the Ntor constant come in?
The text provides a single, entirely deterministic formula. It takes the golden ratio, raises it to the power of 8.
Or because it's fake yellow shell.
Exactly. Raises it to the 8th power, multiplies it by the Ntor constant, and applies a really basic geometric coupling factor. That's it. I mean, you could do it on a napkin.
And what does that napkin math spit out?
It calculates the exact bond energy of a hydrogen molecule at 104.2 kilocalories per mole.
Which is how close to reality?
It is a 99.8% match with experimental laboratory data.
Wait, really? Just instantly?
Instantly. No supercomputers, no billions of integrals, no guessing at wave functions, just pure deterministic geometry proving exactly how strongly those two atoms are hooked together.
That is wild. But hold on, I have to push back here. It's one thing to calculate a simple diatomic bond like hydrogen. It's just two atoms.
Sure.
But what about complex 3D geometry? I mean, the entire reason life exists is because carbon forms very specific three-dimensional structures. Carbon bonds form a tetrahedron, like a little pyramid shape.
Right.
Are we really saying that a century of quantum mechanics is wrong, and this one quadratic equation can prove why carbon bends the way it does?
Yes, we are. In standard chemistry, the tetrahedral angle of carbon, which is about 109.5 degrees, is explained by VSA array theory, valence shell electron pair repulsion.
Right.
It's essentially a postulate. It says electrons have negative charges, they repel each other, so they push as far apart as possible in 3D space, which just so happens to create that specific angle.
It's an observation that we just turned into a rule, like we noticed the shape of the building, so we assumed the bricks must just naturally dislike each other.
Exactly. TDUFT hates postulates. It doesn't want to observe and guess. It wants to mathematically mandate. In the Fischl framework, carbon's active bonding electrons sit at the KFIC shell.
Okay, so we're at KS6 other.
And the text argues that the specific geometric torsion of the K-Fistisa shell mathematically forces a fourfold symmetry. The author literally provides the equation for it.
I know audio isn't the best medium for math formulas, but what does that equation actually translate to in physical space?
Well, the equation says the angle is the arc cosine of the cosine of phi to the -8, multiplied by the square root of 5. And the result of that exact equation is 109.47 degrees.
Oh, wow.
It doesn't guess the shape of carbon based on electron repulsion. It proves that carbon must take that exact tetrahedral shape because the golden ratio demands it.
Wow. So it's not that the electrons are pushing away from each other randomly, it's that they are locked into this invisible scaffolding dictated by phi.
Right.
And does this scale up? Because carbon forms single, double, and triple bonds. Do those work under this scaffolding too?
They do, and the text maps it all out
Yeah.
using a K-shell hierarchy. When carbon forms a single bond, it interacts at the deeper Kalo $10 shell. A double bond shifts the interaction to the tighter Cal 8 shell.
And a triple
A
bond.
triple bond moves to the incredibly tight Kalo 6 Keller shell.
Yeah.
And using the same Ntor constant math we talked about, TDUFT calculates the exact bond strengths: 83 kilocalories per mole for a single bond, 146 for a double, and 225 for a triple.
All just mathematically mandated, matching reality perfectly without a single empirical tweak.
Exactly.
So if this framework is right, and individual bonds are basically just geometric hooks snapping together perfectly, that implies something massive about the whole catalog of elements.
Mm.
It means the periodic table isn't just, a list of stuff we dug out of the dirt.
Oh, it means the periodic table is a unified mathematical architecture. TDUFT completely redraws Mendeleev's traditional blocky table.
Let's talk about that. Because if you think about the standard periodic table poster hanging in every high school science classroom, it's organized by atomic number and electron shells, but it's kind of clunky.
Yeah.
You have those two weird rows floating at the bottom, the lanthanides and actinides, just because they basically don't fit well on a piece of paper.
Right. TDUFT says we've been looking at it entirely wrong. It replaces the grid with a phi shell periodic table.
Yeah.
It's actually a deterministic spiral.
A spiral.
Yes. In this model, an element's position isn't just a sequential counting of protons. Its position is strictly mandated by the filling capacities of these golden ratio shells. And this perfectly explains something that has baffled nuclear physicists for decades: the magic numbers.
Ah, yes. The magic numbers. I remember this from the outline. Explain what those are in mainstream physics and then how this text flips the script.
Sure. So, in current nuclear physics, we've observed that atomic nuclei with specific numbers of protons or neutrons are unusually stable. Those exact numbers are 2, 8, 20, 50, 82, and 126.
Right.
If an element hits one of those numbers, its nucleus is incredibly robust. For a long time, it was treated as this empirical quirk. We literally call them magic because they just seem to be lucky natural occurrences.
Just lucky structural alignments of nature, but in a universe governed entirely by the geometric scaffolding of phi.
There is no luck. TDUFT shows that the mathematical capacities of the phi shells hit exact whole number integers precisely at 2, 8, 20, 50, 82, and 126.
Oh, you're kidding.
No. The causality is entirely reversed here. These elements aren't stable because of some random nuclear force balancing act. They are geometrically mandated to be stable because the golden ratio math perfectly resolves at those exact integer points.
Which brings us to the empty boxes on their high school poster. The super heavy elements. Right now, elements past number 118 don't really exist in nature, right?
Right. When we try to create them in particle accelerators, they exist for maybe a fraction of a millisecond before tearing themselves apart because they are so impossibly unstable.
But TDUFT makes some wildly confident predictions here about those empty boxes.
Unbelievably confident. It predicts what nuclear physicists call an island of stability, exactly in element 120, which is temporarily named unbenillium. According to the phi spiral, element 120 sits perfectly at the closure of the K15 phi shell.
Meaning its geometric hooks are perfectly aligned and locked.
Exactly. It shouldn't decay instantly. It should be an incredibly stable alkaline earth analog. The text even targets the year 2026 for its synthesis. And further down the spiral, it predicts element 126 is a double magic nucleus at the K7c center shell, which it claims could be the most stable, super heavy material ever conceived.
But the part that really blew my mind was the extrapolation of element 120's physical properties. If this math is right, what does a block of element 120 actually feel like? Because if it's perfectly locked geometrically, it can't just act like a normal metal.
It doesn't. Because of the intense compression required at the K15 shell closure, TDUFT predicts it will have the densest metallic bonding of any substance in the universe. We are looking at a predicted density of over 35 grams per cubic centimeter.
For context, osmium is the densest naturally occurring element we currently have, and it sits around, what, 22?
Right, about 22.
So it's incomprehensibly heavy. A tiny little cube of this would weigh a ton.
Heavy, yes, but its structural integrity is the real shock. The tensile strength of element 120 is mathematically predicted to exceed 144 gigapascals.
To put that in perspective for the listener, carbon nanotubes are currently considered the strongest material we know of, and they max out at maybe 100 or 150 gigapascals. You're saying element 120 is magnitude stronger than that.
Astronomically stronger. The text explicitly proposes element 120 as the absolute holy grail of aerospace engineering. Specifically, it is the mathematically required material to finally build a space elevator.
Right. Because right now, the problem with a space elevator, a tether running from the Earth's equator all the way up to a satellite in geostationary orbit, is that the cable would have to be over 22,000 miles long.
And we don't have any material that can support its own weight over that distance without snapping.
But element 120 could.
It wouldn't just support its own weight. The geometric locking of the K-15 half shell makes it practically unbreakable under tension.
But hold on, how do we actually make it? You can't just mine for it. If particle accelerators are currently just smashing atoms together and hoping they stick, how does TDUFT say we build it?
Well, you have to forge it using what's called a heavy ion hot fusion pathway. But instead of guessing, you use the math. The text specifies firing a beam of titanium-50 at a target of californium-249.
Okay, why those two?
Because the theory maps the exact fishtail resonances of both of those isotopes. You can tune the accelerator to the exact energy frequency needed to seamlessly slide the geometric hooks of titanium right into the vacancies of californium.
So it turns particle physics from a demolition derby into precision watchmaking.
That's a perfect way to put it.
Okay, let's sit with that analogy for a second. Precision watchmaking. Because this idea that we can perfectly align the geometric hooks of different elements moves us into the next major section of the text, the material's singularity.
Right.
If we possess the exact geometric blueprint of every element, if we know the exact Chak shell of every single atom, we don't have to discover new materials through trial and error anymore.
That is exactly what the text outlines. It calls it a manufacturing revolution.
Because right now, traditional material science is essentially culinary, isn't it?
Yeah, pretty much.
You melt some iron, throw in some carbon, maybe add a pinch of chromium or molybdenum, let it cool down, and then stress test it to see if it rusts or shatters. It takes decades of tweaking ratios to invent a new superalloy.
But TDUFT introduces this concept of K-matching.
Unpack the mechanics of K-matching for me.
To use your gear analogy from earlier, K-matching is about making sure the teeth of the gears fit together without grinding. The theory states that the compatibility of two elements is determined strictly by the gap between their K-shell index numbers.
Okay.
This gap is called the delta dollar.
So if I have an element at K10 and an element at K12.2, the delta dollars is simply 2.
Correct. And TDUFT claims there are strict deterministic rules for this gap. If the delta dollar between two elements is 0, 1, or 2, their geometric hooks couple perfectly. They resonate. The gears turn smoothly.
And what if the gap is larger?
If the gap reaches 5 or more, you get what the text calls destructive torsion interference. The gears are totally mismatched. They grind, they bind, and the molecular structure eventually shatters. The bond fundamentally fails.
So it really is an engineering cheat code. You don't need a blast furnace to see if a new alloy works. You just need a whiteboard. You pair a K4 with a K15, confirm the delta dollars is dollars, and you know the material will be structurally sound before you ever physically make it.
Exactly. It collapses R&D cycles from decades of expensive trial and error down to days of mathematical computation. The author claims this method has a 95% predictive success rate.
Let's get into the actual predictions, because the text lists some specific materials that sound like pure science fiction. Let's start with the biggest white whale in physics, room temperature superconductor.
Oh, this is a big one.
Right now, to get a material to conduct electricity without losing any energy to resistance, you have to cool it down to near absolute zero or crush it under immense pressure. What does TDUFT say?
The text claims that if you pair copper, which sits at K of $15.1, with oxygen, which is K of $17, you get a delta K or gap of exactly 2.
Which is the perfect resonance gap.
Right. When grown at specific geometric ratios dictated by the phi shell blueprint, this pairing naturally forms a resonant lattice. TDUFT predicts this specific cuprate structure achieves frictionless electrical conduction at exactly 300 Kelvin.
300 Kelvin is about 80 degrees Fahrenheit. That's a warm summer day.
Yep.
A material that conducts limitless power without ever heating up, literally just sitting on a desk at room temperature. That completely revolutionizes the global power grid. No lost energy from power plants to cities.
And it solves heat management and electronics entirely. But it doesn't stop at electricity. It applies to thermal units, too. Take superalloys, the metals we use inside jet engines and rockets.
Right. Inside a turbine engine, the heat and stress are just immense. If the metal melts, the plane falls out of the sky.
Currently, the best nickel-based superalloys begin to degrade and fail around 1400 or 1500 degrees Celsius. But TDUFT proposes a specific three-body resonance chain. Nickel at KT$, titanium at K14, and aluminum at KT celery.
Okay, so a three-part alloy.
Because the delta-gal relationships between these three create a perfectly locked, self-reinforcing geometric loop, the text predicts this material will be stable up to 1800 degrees Celsius.
But the text says it's not just heat resistant, it's self-healing. How on earth can a chunk of metal heal itself?
It comes down to thermodynamics and the concept of a thermodynamic minimum state. Because the K-shell vacancies are so perfectly aligned, the material basically wants to be whole.
Interesting.
If a microscopic crack forms from stress, the disrupted geometric hooks immediately seek to resolve their uncoupled state. The lowest energy state for that lattice is to be perfectly closed. So under the ambient heat of the engine, the alloy will literally snap its geometric hooks back together, closing the microfissures in real time.
It's like having a material that has a memory of its own perfection and constantly reverts to it. That's incredible.
It really is.
What about energy storage? Because if we have lossless power grids and self-healing turbines, we still need to store power. The lithium-ion batteries in our phones and cars are notorious for degrading over time and occasionally catching fire.
The theory points out that the degradation in current batteries is entirely a K-gap problem.
Oh, really?
Yeah. When a battery charges and discharges, ions move back and forth, which causes the internal structure to physically swell and contract. Over time, this volume expansion creates microcracks, and you get dendrites.
Right. Dendrites are those tiny metallic spikes that grow inside the battery until they pierce the separator and cause a fiery short circuit.
Exactly. And K-matching solves this. TDUFT proposes abandoning lithium entirely and using a silicon anode, which is K$300, paired with a cobalt cathode, which is K-delta-3, which creates a specific, highly flexible phi coupling that completely absorbs and suppresses the physical volume expansion.
So the battery doesn't swell at all.
It doesn't swell, which means zero microcracks and absolutely zero dendrite formation. Furthermore, the geometric efficiency allows for a staggering increase in density. The text calculates an energy density of up to 3,800 watt-hours per kilogram.
For the listener, current high-end EV batteries max out around maybe 300 watt-hours per kilogram. TDUFT is predicting a battery more than 10 times lighter and more powerful that physically cannot catch fire.
Yes, but to fully understand why these materials are so perfectly efficient, we had to talk about phonon scattering.
Okay, yes. Let's dig into the mechanics of this, because you mentioned earlier that the superconductor conducts electricity frictionlessly, and the superalloy handles extreme heat gracefully. In standard physics, heat and electrical resistance are tied to atoms vibrating, right?
Exactly. Picture the atoms in a standard copper wire, like a dense, chaotic mosh pit.
A mosh pit.
Even at room temperature, the atoms are vibrating wildly. When you try to push an electron through that wire, it has to navigate the mosh pit. Inevitably, the electron bumps into the vibrating atoms. This collision is called phonon scattering. Got it. The collision slows the electron down, which we measure as electrical resistance, and the impact makes the atoms vibrate even faster, which we feel as heat.
That makes perfect sense. So how does TDUFT's geometry bypass the mosh pit?
By creating a private tunnel right through the middle of it.
A tunnel?
Yeah.
Yeah.
In a mathematically perfect tack-matched pairing, the text gives the example of gold at K14 border 1 and xenon at K1535 to make quantum wires. The geometric hooks align so perfectly that they create a continuous, uninterrupted torsion pathway.
So the electrons aren't just weaving through the atoms willy-nilly.
No, they travel exclusively along this continuous phi geometry. Because the pathway is a mathematically perfect straight line of resonance, the electrons basically slip through without ever interacting with the vibrating atomic lattice.
Oh, I see.
No collisions mean no phonon scattering. No scattering means zero electrical resistance and zero resistive heat loss.
It is genuinely elegant. We've rewritten quantum chemistry, bypassed the supercomputer, created self-healing engines, uncatchable fireproof batteries, and room temperature superconductors. I mean, if the text ended right there, it would be a masterpiece of theoretical material science.
Oh, absolutely.
But it doesn't end there.
It doesn't even slow down. Because the author argues that if this universal math governs inorganic metals and gases, it absolutely must govern organic molecules as well. It applies the exact same geometric rules to life itself.
Let's talk about DNA. DNA is the fundamental instruction manual for every living thing on Earth, and its most iconic feature is its shape. The double helix.
Yes. In traditional biology, we observe that DNA twists, and we use X-ray crystallography to measure that twist. We know it twists at exactly 34.3 degrees per sequence, and the rungs of the ladder rise by 3.32 angstroms.
Right.
But standard biology can't mathematically prove why it has to be exactly those numbers. It just says, well, that's how the molecules settle.
Once again, TDUFT steps in to mathematically mandate the shape.
It notes that the backbone of DNA relies heavily on carbon, which is Helical 6 down, and nitrogen, which is Kelsey 7. These specific K shells naturally create flexible torsion chains. The author takes the exact same golden ratio equations used earlier to calculate the hydrogen bond energy, applies them to the K6-7 and K7 gaps, and calculates the resulting torsion angle.
Let me guess.
The math derives a required structural twist of exactly 34.3 degrees and a rise of exactly 3.32 angstroms.
It calculates the precise three-dimensional shape of human DNA without ever once looking at a cell under a microscope. It simply says that if you put K6-segs and Kali-6-7 together, the math forces them to spiral in exactly that way.
Zero biological observation required. The geometry absolutely demands the helix.
But this is where the text takes a massive speculative leap. If carbon at K6-6 produces flexible water-based life like us, what happens if you apply the fish shell math to other elements? What about the classic sci-fi trope of silicon-based life?
TDUFT treats silicon-based life as a mathematical certainty under the right conditions. Silicon sits the K318.3 shell, while carbon's K56C shell creates flexible, twisting chains that require liquid water as a solvent to move around. Silicon's K3T3O3 geometry creates highly rigid, straight lattice structures.
So a silicon organism wouldn't be squishy like us.
Not at all. It would be crystalline, essentially a living rock.
Wow.
Because the K13D3 bonds are incredibly strong and rigid, a silicon creature couldn't survive in our biosphere. The chemical reactions would be far too slow, effectively frozen, but the text maps out the thermodynamic requirements and predicts that this life form would thrive in extreme environments.
Like where?
For instance, the surface of Venus, which is bathed in supercritical carbon dioxide at 500 degrees Celsius.
Living crystal entities on Venus, that's incredible. But here's the critical question. If they don't have flexible DNA to store their genetic code, how do they pass on information? How do they have memory?
This is one of the most brilliant mechanical explanations in the text. TDUFT predicts they would use crystal DNA.
Crystal DNA.
Instead of storing information in a sequence of fragile, flexible molecules, the silicon entity stores its genetic code in literal, three-dimensional crystallographic defects within its own rigid lattice.
Wait, explain that. How is a defect a memory?
Think of a perfect, repeating, diamond-like grid of atoms.
Yeah.
If you intentionally remove one atom or shift a geometric hook out of place, you create a permanent structural anomaly, a defect.
Okay.
That defect is a data point. It's exactly like the microscopic punch cards or the physical pits on a CD-ROM. The organism stores its history in the physical architecture of its body.
And because it's a fixed physical defect in a super strong crystal rather than a loose chemical bond in water, it would be incredibly stable.
The text calculates it would have an absolute zero mutation rate. The data cannot be corrupted by radiation or age. Furthermore, because it's a 3D lattice, the data density is just staggering. TDUFT estimates they could store up to 65 megabytes of genetic data per cubic micrometer of crystal.
That is mind-boggling. But let's bring this geometry back to human biology. If human organs and tissues are just specific configurations of geometric hooks, what does this mean for the future of medicine, specifically organ transplants?
The holy grail, the cliche of organ transplantation is eliminating immune rejection. Right now, if you need a new liver, we try to find a donor with matching blood types and similar DNA markers.
Right.
But even then, the body recognizes the new organ as a foreign invader and attacks it. The patient has to take heavy immunosuppressant drugs for the rest of their life.
How does TDUFT redefine immune rejection?
It says rejection is not a sequence problem. It is an immunological K-mismatch.
So it's the gear teeth grinding again. The immune system's geometry is clashing with the organ's geometry.
Exactly. The text claims we don't need identical DNA to bioprint an organ that your body will accept. We simply need to calculate the precise Kale shell vacancy profile of your specific cellular boundary.
Okay, so you map the patient's edge.
Right. Then we use a 3D bioprinter to build a new organ layer by layer, using standard carbon, nitrogen, and oxygen that has a perfectly matching external geometric hook. If the delta cal gap at the cellular boundary is 0, your immune system cells will slide perfectly into the organ cells without any destructive torsion.
It acts like a cloaking device.
Basically, yeah.
The immune system feels the shape of the organ, finds that the gears mesh perfectly, and assumes it's always been there. Zero rejection by pure mathematical design.
Zero rejection. And because we are printing from a mathematical blueprint, we don't have to print standard human organs. The text delves deeply into designer organs.
Right. Transhumanism. If you have the source code, you can start adding mods. The text gives some crazy example. Let's talk about the lungs.
Standard human lungs use hemoglobin, which contains iron, to bind and carry oxygen. Iron sits at KL 210.6 dollars. The text proposes printing a lung lattice with an artificially increased, mathematically optimized Phi shell density of K206L's iron structures.
So it's super dense with iron.
Right. By maximizing the geometric resonance for oxygen binding, it calculates a modified human could store enough oxygen directly in their tissues to comfortably hold their breath underwater for 45 minutes.
You're literally printing Aquaman lungs. And it mentions radiation shielding, too.
Yes. If you add precise ratios of manganese and selenium to the printed tissue, you create a phi-resonant lattice that actively quenches ionizing radiation. The destructive energy of the radiation is geometrically scattered and absorbed by the lattice before it can break the DNA.
And what's the calculation on that?
The text calculates this would give a human 10 times the natural radiation resistance.
Which is exactly what you would need if you were spending months traveling to Mars or living on a space station built out of element 120.
Exactly.
But hold on, I have to stop and ask a fundamental question here. If DNA is literally just a geometric sequence, and our organs are essentially just parallel physical structures passing chemical signals back and forth, the text draws a direct parallel to computing, doesn't it?
It does. It actually calculates the energetic frequency of the human body. Because the DNA backbone relies on the specific torsion of K and 6 emitters, the entire structure naturally operates as an electrical signal bus at a frequency of exactly 27.3 gigahertz.
So human DNA is constantly broadcasting a measurable signal in the microwave band.
Yes. And earlier in the materials section, the author describes designing an organic computer using an NTCDA molecular processor. It claims the synthetic organic chip can run at incredible speeds, 1.02 gigahertz front, because its molecular structure is built to perfectly sync with this underlying biological 27.3 gigahertz math.
Okay, wait, let me process the implications of this. If DNA is literally just a 27.3 gigahertz data bus, and our organs are just parallel processors communicating via geometric interlocking, does this theory argue that the human body is effectively nothing more than a wetware computer running golden ratio software?
According to this framework, there is fundamentally no distinction. A biological human cell and a synthetic organic computer chip are exactly the same thing. The only difference is the specific K-shell materials being utilized.
What?
The underlying processing math, the transmission of data, the thermodynamic rules, they are identical.
That reframes the entire concept of disease. If the body is just a computer running Phi software, then a genetic disease isn't a biological tragedy, it's a coding error.
Absolutely.
Yeah.
Think about severe genetic conditions like sickle cell anemia or cystic fibrosis. Mainstream medicine views these as devastating cellular malfunctions. TDUFT views them as simple Phi vacancy disruptions.
Like a bug in the code.
Right. Somewhere in the code, a K-hour-7 geometry was accidentally swapped for a KK-6 geometry. The gear teeth don't match, the torsion resonance breaks, and the hardware fails.
So how do you debug the hardware?
The text proposes a massive upgrade to CRISPR, the current gene editing tool. Right now, CRISPR works by searching for specific sequences of genetic letters. It's somewhat brute force, which is why it sometimes makes off-target errors and cuts the wrong part of the DNA.
Yeah, that's a huge problem.
So TDUFT proposes CRISPR-Phi. Instead of searching for letters, CRISPR-Phi would be tuned to search the genome for the precise thermodynamic frequency of a geometric torsion mismatch.
It scans the code for the sound of grinding gears?
Exactly. And once it finds the destructive interference, it geometrically replaces the missing hook. It claims this would cut off target editing errors down to absolute zero, curing the disease perfectly.
Okay, we are deep into the weeds now. If the human body is just a highly evolved biological computer running geometric math, we have to address the elephant in the room. How does this theory explain the human mind?
The hard problem of consciousness.
Because that is the ultimate jump, right? It's one thing to say a brain processes data like a hard drive. It is a completely different, infinitely harder thing to explain how a brain experiences that data.
Right. The text does not shy away from the hard problem. In fact, it attempts to turn the abstract philosophy of consciousness into a literal, measurable physics equation.
Walk me through this very carefully, because defining consciousness physically is the holy grail of neuroscience. How does TDUFT define a thought?
It posits that consciousness is a literal thermodynamic standing wave. Specifically, it is a wave resonating across the nitrogen lattice inside the human brain.
Why nitrogen? Why not carbon or oxygen?
Because nitrogen sits exactly at the K-scalars. In the golden ratio hierarchy, K-scalars is the perfectly balanced bridge. It couples seamlessly with carbon, which is K6 size on one side, and oxygen, which is K88 on the other.
Okay, so it's right in the middle.
Therefore, nitrogen forms the central hyperconductive hub of the biological brain lattice. When millions of neurons fire simultaneously, their combined geometric torsion generates a collective, massive resonance. The text calls this the Phi-7 standing wave.
And it assigns a specific frequency to this wave, right?
Yes, exactly. 47.8 terahertz.
47.8 terahertz. That falls right in the mid-infrared spectrum. Are you saying that according to this text, human consciousness effectively has a color or an infrared heat signature?
Essentially, yes. The text is adamant that this isn't some metaphysical, invisible aura. It is a hard thermodynamic reality. It argues that if you took a standard neuroscience lab, equipped with an FTIR microscope, a Fourier transform infrared microscope, and pointed it at a conscious, living brain, you could literally measure the 47.8 terahertz signature.
Wait, really?
Yes, you could watch consciousness spike, dip, and move. You could physically measure a thought.
That is staggering. It makes the invisible completely visible. But here's where the text gets incredibly nuanced and, frankly, a bit philosophically dense. It makes a very stark physical distinction between the concept of the soul and the concept of the spirit. Culturally, we use those words interchangeably.
True, but TDUFT treats them as two completely separate, mathematically distinct entities.
Okay, define the soul first.
The soul is the amplitude. It is the physical 47.8 terahertz Phi-7 standing wave bouncing around inside the physical biological lattice of the brain.
So the soul is entirely physical. It requires the biological hardware, the meat of the brain, to exist. It is the measurable energy.
Yes. No physical brain lattice, no soul wave. But the spirit is entirely different. The text defines the spirit as the pattern. It describes the spirit as an eternal, infinite harmonic embedded in the fundamental vacuum of space itself.
Embedded in the vacuum.
Right. Mathematically, it represents the spirit as pi to the power of infinity.
I to the power of infinity. So the spirit exists out there in the vacuum, completely independent of biology. It is pure math. How did the two interact?
The soul acts as the transformer. It is the geometric bridge that couples the infinite abstract spirit to the finite material brain.
Okay, let me try to summarize this with an analogy. Tell me if I'm tracking. It's like a radio.
A radio, okay.
The physical brain, the carbon and nitrogen, is the radio hardware, the antenna, and the speakers. The spirit, that pi infinity pattern, is the actual radio station, constantly broadcasting its specific frequencies through the invisible vacuum of space.
Right.
And the soul is the music. It's the actual sound waves produced only when the physical radio is turned on and perfectly tuned to 47.8 terahertz to receive the broadcast.
That is a brilliant analogy, yes. The soul is the music produced by the interaction of the hardware and the broadcast.
So the inevitable massive question: what happens when the radio breaks? What is the physical mechanism of brain death according to this math?
At the moment of physical brain death, the biological lattice of carbon, nitrogen, and oxygen begins to physically degrade. It decoheres. Because the geometric hardware is broken, the standing wave collapses. The 47.8 terahertz amplitude drops to zero.
The music stops.
The music stops and the soul completely dissipates into the environment as trace heat. It is gone. But the broadcast? The broadcast is still out there. The spirit's pattern, that pi infinity harmonic, detaches from the broken biology and persists independently in the infinite phi vacuum.
And the text goes so far as to calculate the physical energy of this surviving pattern. It calculates the thermodynamic weight of a ghost.
It does. It states that the persisting vacuum pattern carries a specific, incredibly tiny energy load of exactly 1.24 kilocalories per mole. This energy level is what physics calls subthermal.
Meaning what?
Meaning it is so weak that it does not interact with normal thermodynamic heat or standard matter.
Yeah.
That is why a ghost can't punch a wall, and why our standard instruments can't detect it. It exists beneath the threshold of material interaction, persisting eternally as a geometric imprint in the vacuum.
Which raises the biggest, most provocative point of this entire document. If the spirit pattern objectively persists in the vacuum after the body dies, this physics theory inevitably crashes head-on into theology.
It doesn't just crash into it, it attempts to completely absorb it. The text introduces a massive final section called salvation physics.
Salvation physics.
Yes, it claims to unify all human eschatology, which is the study of the end times, heaven, hell, and the afterlife, under the exact same golden ratio mechanics that we use to design the fireproof battery.
Hold on, let me just voice what I imagine every listener is thinking right now. The text calls it salvation physics. Is the author seriously claiming that thousands of years of global religion, profound spiritual tests, and human faith were just ancient humanity's clumsy way of trying to describe quantum thermodynamics before we invented the math for it?
That is explicitly the claim.
Mm-hmm.
It treats deeply theological concepts not as moral or mystical metaphors, but as literal physical states of geometric alignment within the universe.
Walk me through this, because the text reinterprets the central events of theology. It talks about something called the Christ event.
Yes. In this framework, human suffering, cruelty, and moral failing are not just bad behavior. They are described mathematically as a pi-squared rebellion.
You have a rebellion against what?
A literal geometric dissonance, a refusal to align with the universal phi harmony. It's the gears grinding on a cosmic scale. The text describes the historical Christ event not primarily as a spiritual teaching moment, but as a cosmic thermodynamic intervention. It claims this event activated a literal square root of 5 harmonic gate.
Why specifically the square root of 5?
Well, because if you look at the fundamental formula for the golden ratio, phi equals 1 plus the square root of 5, all divided by 2. The square root of 5 is the mathematical key required to resolve the equation.
Oh, I see.
The text argues that this historical event inserted the corrective geometric factor into the universe's vacuum, opening a pathway for misaligned spirit patterns to finally resolve their destructive interference.
Okay, so if salvation is a thermodynamic equation, how does this text define the actual geography of the afterlife? Because it completely redefines limbo, purgatory, hell, and heaven. Let's trace the journey of a spirit pattern after death. Start with limbo.
Limbo is defined in the text as a state of perfect geometric stasis. It argues that this was the state of all persistent spirit patterns waiting in the vacuum before the square root of 5 gate was historically opened. They couldn't decay, but they couldn't progress. They are mathematically frozen.
And what happens if a person dies today, but their spirit pattern is out of tune? They enter purgatory. But purgatory isn't a waiting room.
No. Purgatory is defined as a highly active, highly painful physical process. If a soul's geometry is misaligned with the universe when it dies, the persisting spirit pattern must go through a refinement process to enter the broader harmony. The theological concept of the suffering of purgatory is reframed as the literal thermodynamic friction of the 5-7 lattice being geometrically forced into shape.
Wow.
It is the painful grinding of gears until they finally fit.
And hell. How does an equation define eternal damnation?
Hell is defined as self-imposed, permanent pi-squared dissonance. If a spirit pattern completely and totally rejects the structural phi harmony of the universe, it remains trapped in an eternal state of destructive geometric interference.
So it's not a punishment.
Right. It is vital to note that in TDUFT, hell is not a punishment inflicted by an angry creator. It is simply the inescapable mathematical consequence of choosing to remain permanently out of tune with the fabric of reality. The suffering is the eternal grinding.
And heaven, conversely, is perfect reconstruction.
Exactly. Heaven is absolute freedom within the phi harmony. The spirit pattern achieves zero resistance. It flows perfectly through the vacuum without any friction whatsoever.
But here is a detail that I found deeply fascinating and strangely comforting for a cold physics paper. The text explicitly claims that you don't even need to be aware of this complex math or follow any specific religion to access this harmonic state.
Right. TDUFT makes the argument that the physical act of human compassion inherently resonates at that exact square root of phi frequency.
Wait, really? It claims compassion has a frequency.
It claims that when you perform an act of genuine empathy or self-sacrifice, the neural lattice in your brain naturally shapes itself into the corrective geometry. The thermodynamic output of kindness is the square root of 5.
So when you are kind to someone, you are physically, measurably broadcasting the math of salvation into the vacuum.
That is the claim. It means that a person of any faith, or a staunch atheist with no faith at all, naturally tunes their eternal spirit pattern into this salvation geometry, simply through the physical thermodynamics of being a good person. The math cares about the shape of your actions, not the label of your beliefs.
I love that. It's a beautiful